Hey, welcome back. So in this third part, we are specifically going to see the functions or the continuity of a function over a specific domain. So if you have not watched the concept video, please go and hit the I card or the I button and you can see the whole entire video of the concept and then come back. So I have told you that in a particular domain, you have to check the continuity. What do I mean by this is, if you are given a question like this, what they'll ask you is from 0 to 3, this particular function is applied. And from 3 to 6, this particular function x plus 3 is applied. Well, in this case, what you need to check is, you need to check the continuity at a common point. So in this case, you have the common point as 3, and in these two cases, you have a common point as 6. So I don't think so this question should be in your textbook. It is that easy. So we'll try to jump start it and solve it in a easy way. So in this case, so it is 1 upon 2 and 1 upon 2 in this particular 11th question. So f of x is equals to x, this is slightly x, okay, so this is x. So if you plug in half value, it will become f of x at limit x tends to half will become 1 upon 2, right? So since we can directly plug that value, and since we know that it is less than and this is just towards tending towards less, so at 1 upon 2, so at f at 1 upon 2, since we have an equal sign over here, it is 1 minus x. So what is x? It is 1 half. So it basically becomes 1 upon 2. So these two values are equal. So we can say that it is a continuous function. Now we will try to take a look at the 12th question. For the 12th question, we are going to check the continuity. And in this case, we can see that x is not equals to 3 in this case, but in the second function it is equals to 3. So we can say that the second function, we have the f of 3. So f of 3 we can directly see from these equations, which is equals to x plus 3. So since x is 3, we can see this function as 6, but we have to equate it to this, right? So limit x tends to 3 f of x square minus 9 upon x minus 3. Now we need to just factorize it. This is also a 10th standard problem. So x square minus 9 can be stated as x minus 3 times x plus 3, and now everything divided by x minus 3. So you can just cut this off, and then again when you plug in the value, you have an answer as 6. So you can say that at x equals to 3, this function is continuous. Now we will not solve the second problem, like the second in this particular question. We will try to solve it orally. So at x tending towards 6, what will be the value of this function? It will be 6 plus 3, which is 9. And now we will try to look if that is equals to right hand side. So when x is equals to 6, what will this happen? X square minus 9 upon x plus 3, it will be x minus 3 times x plus 3. So x plus 3 and x plus 3 will get cancelled, and what will happen is we have x minus 3. So just this function is getting cancelled and we have x minus 3 over here. So x minus 3 is what? 6 minus 3. So 6 minus 3 is 3, which is not equals to 9. So we can say that this function is discontinuous. Now we'll take the 13th question, which says that the angle x for particular this function is between 0 to pi by 2 and it equates to pi by 2 in the first function. So immediately what we can say is f of pi by 2 can be stated as limit x tends to pi by 2 of this function. So sine 2x can be written as 2 sine x cos of x, and 1 minus cos of 2x can be written as 2 sine square x. So when you have 2 sine square x under root, you can take that root out and you can say that it's simply as sine of x. Now watch carefully what happens. This is sine of x will get cancelled, and what is cos of pi by 2? Cos of pi by 2 is nothing but 0. So the value here becomes cos of 90, which is 0. Now this is what value which we have particularly got for f of pi by 2, right? Now we need what is the value of this function in order to check the continuity. So limit x tends to pi by 2 for f of x this particular function will be cos of x everything divided by pi minus 2x. Now if you try to substitute this value as t, so let's say t can be pi minus 2x. So when x is approaching pi by 2, pi minus pi, so t will approach towards 0. When also x can be stated as, so what will be x will be pi by 2 minus t by 2. So that comes from the simplification problem. So this cos of x will become cos of pi by 2 minus t by 2, everything divided by t. Now we have the problem as cos of 90 minus theta. So what is cos of 90 minus theta? It is essentially sin theta. So what is theta over here? T by 2. So it will become sin t upon 2, everything divided by t, and limit t tends to 0. You don't need to write it every time, but just for your understanding purpose I am writing. So this you can divide it as upon 2 and then you can multiply by 2. So your answer is 2 in this case, which is not equals to 0. So you can see that this function is discontinuous. Now we'll try to look at the 14th question, which is given as e raised to 1 upon x minus 1 divided by e raised to 1 upon x plus 1. Well, at first it seems very tough to solve since x is tending towards 0 and 1 upon 0 can essentially be stated as, well, infinity, right? And we have a problem over here. So how can we solve this, or how can we approach this? So I have a very nice trick to handle this. Okay, so first take numerator, right? So limit, we know that f of 0 is 1, which is obviously given at x equals to 0. Well, x tends to 0 for e raised to 1 upon x minus 1, everything divided by e raised to 1 upon x plus 1. Now we know a particular formula that e raised to f of x minus 1 divided by f of x, when limit x tends to f of x tending towards 0, this is particularly 1, right? So we can use this formula and turn this example into such a formula, right? So we can say that e raised to 1 upon x minus 1, everything divided by 1 upon x, and then we can multiply that by 1 upon x, right? And we can also write this as 1 upon x minus 1. Since we have subtracted minus 1, we have to add that 1. So 1 when adds to 1, it will get 2. Now what we need to do is, we need to divide this whole term by 1 upon x, and then we have to again multiply it by 1 upon x. So this seems very legitimate to understand whole problem, and since this will become 1, in the numerator you have 1 upon x, and in the denominator what you have is 1 upon x plus 2. So you can state this as 1 upon x upon 1 upon x plus 2. So within 2 steps you have reached from a particular level up onto the second level within no time. So now if you look at this problem, you can technically shift it to 1 upon x can come to numerator, and this will become 1 plus 2x. So you have 1x over here, which is this, and the other x from this particular denominator will go on the upside. So this gets cancelled, and now what you are particularly looking at, x is tending towards 0. So what will be this value? It will be 1 plus 2 times 0, which is basically 1 upon 1. So it is 1. So this function is continuous. So now we will see the 15th problem. Well, x plus 3x square plus 5x cube so on until 2n minus 1 times x raised to n is very easy to understand. But what is this minus n square? It necessarily means that if there are 2 terms, it will be minus 4. So what we can see is n square is equals to 1 plus 3 plus 5, which is 1 plus 3 plus 5 so on till 2n minus 1. How? If we take 2 terms, if we take n equals to 2, you will take first 2 terms, which is 1 plus 3, which is 4. So 2 squared is 4. So this equation particularly satisfies what is n square. So we need to plug in this n square in this equation. So what we will have is x plus 3x square plus 5x cube minus now what we have is, we have 1 minus 3 minus 5. Since we have a negative sign, we have all those terms, and so on till 2n minus 1 x raised to n till 2n minus 1. So if we take common out of these, what we have is, see, here we have 1 common and here we have 1. So what we can say is, if we take 1 common out, we have x minus 1. Between these two we have 3 common, so you have x square minus 1, and if you go on, you have x cube minus 1. So this is your numerator, which is 2n minus 1 x raised to n minus 1. So this is your revised numerator. Now we'll take the example. So limit x tends to 1 f of x, right? F of x. Since we know the f of 1 value, so this is f of 1 particular, right? So what we'll do is, we have revised the numerator as x minus 1 plus 3 times x square minus 1 plus 5 times x cube minus 1, and so on till 2n minus 1 x raised to n minus 1. Everything divided by x minus 1. So now you know where I am going at. We can divide x minus 1 from each of these terms, and what we have is x minus 1 divided by x minus 1 plus 3 times x square minus 1 divided by x minus 1. Then again we have 5 times x cube minus 1 divided by x minus 1. And you can go on doing like this till 2n minus 1 you have, and then you have x raised to n minus 1 upon x minus 1. And now watch carefully what I do. See, when you apply limit to all these functions, right? So when you apply limit x tends to 1 to all these functions, or this particular function, what you'll get is, this function will become x minus 1 times x plus 1. So similarly, in each term you will have x minus 1 as common, and what you'll get is 1 plus x, which can say that x plus 1. So when you plug in one value, in the second term you'll get the value as 2. So in the third term you'll get x minus 1. So x cube minus 1 can also be written as x minus 1 times x square plus x plus 1. So what you will get is, when you plug in x equals to 1, 1 plus 1 plus 1. So in the third term you are getting the value as 3. In the fourth you will get 4, and so on up until the nth you will get the value as n. So we can write this as 1 plus 3 times 2 plus 5 times 3, and so on till 2n minus 1 times the nth term, so it is n. So what we need to see this is, this value has to get some specific value in terms of n. But what is n, or rather what are the products? So you can see that the first number is odd and the second number is regular series, like 1 2 3 4. So for the first series we'll check if we can find the product. So what is the summation? It is nothing but summation of r from 1 to n. So from 1 to n of 2r minus 1 times r, which is basically, this is the odd series and this is the regular number series. Well, we'll see what happens over here. So summating 2r square minus summation r. Well, what is r square series? It is nothing but n into n plus 1 into 2n plus 1 upon 6. This is the summation of all the squares of natural numbers. So this will be into 2 minus n into n plus 1 upon 2. So if you look at this, you can cancel this out as 3, and then you have n into n plus 1 common. So you have n into n plus 1 times, so you have 2n plus 1 upon 3 minus 1 upon 2. Now you have 4n plus 2 minus 3. So 4n plus 2 minus 3, if we take the LCM, divided by 6. and then you have n to n plus 1. So what is 4n plus 2 minus 3? It can be stated as 4n minus 1 divided by 6 into n plus 1, which is exactly this term. And now you can say that this function is continuous, since the value at x equals to 1, which is f of 1, is equals to f of x, and hence the function is continuous. In the next video, we are going to completely solve the exercise 5.1 of NCERT book, which is the CBSE book, and after that we'll find out the 2 more questions from the 1.1 exercises of Mathematics Maharashtra State Board Continuity chapter of part 2. Thanks for watching.